Given any 2 points, you have enough information to sketch a line. My question to you is, why not use the 2 most important points to get a really accurate graph? Those 2 points are the x-intercept and the y-intercept. As a reminder, the x-intercept is where the graph crosses the x-axis, and the y-intercept is where the graph crosses the y-axis. How do you find these? To find the x-intercept, you set y equal to 0, and you solve for x. This will give you a single number that represents the point that you can find your x-intercept at. To find the y-intercept, you do the complete opposite. X equals 0, solve for y. These sound like, okay, wait, I have to solve 2 equations, but the equations that come out are actually pretty straightforward and pretty simple and fast. That's the main point of this method. Instead of plotting random points, you're plotting 2 specific ones. As an example, we're going to start out with something pretty easy. You'll see why it's easy in a second. I'm first going to find my x-intercept. Remember, first that means I'm going to set y equal to 0. I get 0 equals 2x plus 4. Okay, I got to get rid of the 4, so subtract from both sides. Minus 4 equals 2x. X would then be minus 2. That means I have an x-intercept of minus 2. The actual point is minus 2 comma 0, but I don't actually need that information to plot this. Okay, what about the y-intercept? If you're pretty familiar with these types of graphs, you know that this is going to be our y-intercept, right? Because it's of the form y equals mx plus b, and that number represents your y-intercept. If you don't remember that, you can still find it using this method. Just remember, y-intercept set x equal to 0. So I'd have y equals 2 times 0 plus 4, but what's 2 times 0? It's 0, so y equals 4. That gives me the point 4 as my y-intercept. Now all I have to do is connect these 2 points with a line going through them, and I have my line for this equation. What if it's not in that form y equals mx plus b? Will it still be that easy? Well, it turns out it's still pretty good. It's still maybe even a little bit easier because you don't have to move things to other sides of the equation. Let's see what I mean. I'm going to start out by finding my x-intercept. That means I'm setting y equal to 0. So I have 3x plus 5 times 0 equals 7. So 3x equals 7. Solve for x by dividing by 3, I get 7/3. Now 7/3 is not something that's easy to just graph. It's best to find the decimal approximation for that and try to graph that. This is about 2.3. In other words, a little bit past 2. So my x-intercept, here's 2, is just a little bit past that. Remember, you can't draw a perfect graph by hand, but you want to draw it as accurately as possible. Okay, what about the y-intercept? For the y-intercept, I'm going to set x equal to 0. I'm going to have 3 times 0 now plus 5y equals 7. In other words, 5y equals 7, and y is 7 over 5. 7 over 5 is approximately 1.4. And again, the way I found that was I put it in my calculator. I did 7 divided by 5. So if this is 2, this is 1, and we want just a little above 1, so there's that intercept. Now again, like before, all I have to do is draw my line through these 2 points, and I've graphed the equation.